Welcome to Walk About the Galaxy, the non-eclipsing astronomy podcast, where the science is universal, the opinions are personal, and no one ever gets in the way. We are Strange, Charm, and Top, the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. We are also on the World Wide Web at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. Speaking of our shirts, we have a winner of our Walkabout t-shirt giveaway with our the winning guess for the Blue Origin bid.
Yeah.
And when the winning guess was $14.6 million, and I was sure when that came in, I was like, this fool doesn't know what he's talking about. And it was actually, because I thought it was way too high.
Yeah.
And then the winning bid ended up being
$28
million.
That's
almost
Did
twice
you know
as much as the...
that Garriott, when he went to the ISS for a week, paid $30 million.
Right. So there's a little bit
And maybe there's inflation, but like,
yeah.
Wow.
Yeah.
Wow.
So congratulations to Drew from Colorado.
Yay. Congrats,
for
Drew.
the winning guess, and he'll be receiving 2 Walk About the Galaxy t-shirts.
Wow.
Not at all surprising that Drew won this, because I think we found out that Drew is an alumnus of St. Mary's College of Maryland, where I got my undergraduate degree as well.
Wow.
And everybody that-
True. Those
who graduates
people are
from there are super
naturally
geniuses. Yeah.
super geniuses and
Yeah.
always right. This is true. He's also near our old Colorado stomping grounds.
Boulder?
In Colorado.
Yeah, that's true. That's near our stomping grounds. I did stomp through many places in Colorado.
Speaking of stomping, our stumpers today are nomenclatural.
Okay.
Addie,
Hi.
would you rather have a periodic a periodic object such as an asteroid that is basically inconsequential on its own, but is there forever, named after you, or a spectacular comet that makes one appearance and is gone forever after that? So, and who knows, like 1,000 years from now, people from The Expanse TV show reality future might be living on an asteroid that today may seem
Asteroid Daddy.
nobody knows about. You don't like step outside and see it.
Sure.
And in 1,000 years from now,
Nobody.
Comet Addie, that was a big splash in 2021, will be long forgotten. Nobody will care about it.
Yeah. That's hard. Because like there's going to be good photos, and maybe you're in textbooks for a long time, or like coffee table books if you're a really cool comet.
Maybe.
You'd be in, I don't know if anybody still buys coffee table books, but you'd be on the internet.
Yeah.
Pictures of you would be on the internet.
Yeah.
But if you have an asteroid named after you and it goes into the books and it's legit,
And
it does stay for a while.
Yep.
But then people might stomp all over you.
They might stomp, but
And bore
they'd be
into
like
you.
they'd be stomping around
Yeah.
on.
I think I will choose an asteroid.
Okay. We'll come back to that
'Kay.
in our subject matter later. Jim, it's not quite exactly the same for you since you're not a planetary person.
No.
You could still have these if you want, though.
Would you rather have an obscure but true theorem, law, or rule named after you, or a very important and transformational proposal that everyone hears about, but that turns out not to be correct later, but not stupid?
Right.
Okay, not stupid.
Yeah.
So think, for the latter, think Niels Bohr model of the atom.
Sure.
That actually was, based on physics.
We still teach
And
it.
it actually worked
Yeah.
spectacularly well for
Yeah.
hydrogen and helium, I think.
Yeah.
But it turns out to be incorrect.
Yeah. I'll go with the latter. Go big or go home.
Go big and be wrong.
Go big and wrong. You got to get it. This is how science works sometimes.
Yeah. Well, my for an example of the true but obscure, did you know that there's a Caldwell's rule of New Testament Greek grammar?
It's
Did
named
not
after
know
your
that.
grandfather.
It is.
Nice.
Nice.
Addie did know that.
I
You
didn't know that was a rule, but I.
It is, yeah.
assume-
Caldwell's
I
rule has to
inferred.
do with something about prepositions. But it's
You
a
should
thing.
know Caldwell's rule.
Oh, well, I've known it occasionally,
Yeah.
but it doesn't persist.
Right.
I'm afraid.
Right.
I'm embarrassed to say. Well, today we'll talk about the mystery of Betelgeuse dimming solved,
Solved.
but a new and even mysteriouser giant star dimming called VVVWIT-08.
I was so confused when you sent us the thing. I was like, is this just a weird link thing that's happening?
And my favorite thing about WIT is that, or about this star, and the whole story is that WIT stands for,
What is it?
what is that?
That's amazing.
Oh, yeah. What is that?
What is that?
WII.
So when apparently good old
What
astronomers,
WIT. What?
yeah,
What it?
yeah, WIT.
Yeah, that is
What
weird that gets into the official nomenclature.
That's in the official
That's
nomenclature.
not typical.
They've seen no,
No.
but there are. But this is not the only WIT out there
Oh,
in
that's fun.
space. Yeah,
Is it like their version of a UFO?
kind of. Don't know what it
I
is.
didn't want to say.
What is that? Gets people's attention. Astronomers, maybe amateur astronomers, maybe make more observations of it. We'll also see what we can learn about Enceladus's ice fractures from Antarctica and more asteroid news. But first, this episode of Walk About the Galaxy is brought to you by Gödel's incompleteness theorems. Do you know a know-it-all? Some smug smarty pants in your life who always has an answer for everything? Then maybe you want to get yourself a pair of Gödel's incompleteness theorems. The next time it seems like they're inventing an answer out of thin air, you can remind them that no consistent system of axioms whose theorems can be listed by an algorithm is capable of proving all truths about the arithmetic nature of natural numbers. In other words, you can't know it all. Remember, the best way to never be wrong is to know when to say, I don't know, and then go find out if you can. Gödel's incompleteness theorems. Be all you can be.
I love Gödel's incompleteness theorems.
Can I
It's
tell you
high
something I
time they've
expected?
sponsored
Yeah.
the show.
Can I tell you something I expected from that
Yeah.
sponsor? Is that it would just sort of cut off in the middle.
Oh, that would have been...
Yeah.
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 No,
I was waiting for it the whole time.
There's a really great book, I think, that won the Pulitzer Prize, right? Gödel, Escher, Bach.
Yeah.
That has to
Gesundheit.
do with
Thank you.
how that theorem, is related to the art of MC Escher and in some ways the music of Bach, and it's how human consciousness and experience and everything has to do with this. The incompleteness theorem is like
Find that book.
a much bigger
It's important.
philosophical thing
Right.
than one might think. It
Yes.
is-
Oh, it's scary when math and philosophy are the same.
Oh, it's
Yes.
yeah, it's really creepy. With all it's.
Have you read it, the
I
theorem?
did. I've read.
Or the synopsis of it or
I
something?
read the book,
Okay.
which is a very challenging read,
Okay.
and so I can't claim to have taken all of the lessons that I think I was supposed to take from that book. But
But it's a book about the theorem, among other things,
Right, right.
and not the theorem. And I have not read the whole theorem. I've just read statements of the theorem.
right. That's probably true. as
And
well.
from if it is anything like the proof of Fermat's last theorem,
I don't think it is.
and I read a book about the proof of Fermat's last theorem,
neat.
and I sort of understood that was an entertaining read.
Okay.
And at the end of the book, they had the first page of the proof of Fermat's last theorem, and I recognized many of the words.
Yes, a few of the symbols, many of the words. Yes.
Yes, but the content of the sentences was empty for my poor brain. Be all you can be,
Army.
and I put my own parenthetical aside, but nothing more.
I like it.
Yeah. Space news, Hubble is having some
Oh
computer
no!
trouble.
Yeah, this is very
Those
bad.
computers are pretty old.
They're 80s, right?
Yeah. They're from the 80s.
Yeah.
They're like 30 plus years old.
Yeah. So the last time Hubble was visited was like 09, I think,
I think
was
that's
the last servicing. So it's been 12 years. And prior to that, it was getting serviced like every 3 or 4 years or something like that.
There was an issue a year-ish ago, maybe, where they had to sort of reboot. They went into safe mode and they had to reboot.
Okay.
But I think that wasn't just its computer, but yeah.
So, so are there any updates? I had this a few days ago. I had seen that, and they had ceased science operations.
Right.
But they were attempting to, like, I don't know, some issue with some kind of a memory something, and they were going to switch to a backup that had been installed during the last mission. So it should be newer than the
True, right.
80s, the backup thing. But I didn't hear about whether that was successful.
I haven't heard yet either. I don't know if they've finished trying it.
To be honest, Hubble has had a phenomenal career, and if it's dead, it's dead. I mean, like, it's a bummer, but like, it has done so much already.
Yeah, it's always a bummer when it ends suddenly and surprisingly, and you have like, there's the people who are like planning
waiting
to take
for their
data
observations.
Still.
Yeah, there's a whole bunch. They'd really hoped that it would overlap a little bit with for various reasons with James Webb,
and it still may. I mean, this they're not ringing the death knell just yet.
No, not quite.
Oh, it was just in March that it went into safe mode. It wasn't that long ago.
Oh, really?
It's just been in the endless year that it happened. So.
Yeah. China's space station got a new crew.
You got a crew?
Week. It hasn't had a crew at all.
No. This is the first time. Very exciting.
Three people.
Three
taikonauts.
Yeah.
Yeah.
And there's a space station spacewalk, International Space Station spacewalk earlier this week. And to unfurl some new solar arrays, but there were a couple of issues with it, and so they didn't, both with one of the astronaut suits and then with something else, so it didn't quite get unfurled, but it's pretty set up now.
Okay. How many are they doing?
There's
just one?
2 new arrays.
Okay.
But they were just going to do the one on the first walk and then do another one, but they're...
And these are sort
exciting.
of funny. They're not replacement arrays. They're like supplementary ones that sort of stick off the old ones in a funny direction.
And it's a newer technology, so part of the reason probably for that is like you don't want to take down your old ones, but it's going to allow it to have a lot more power again, which is exciting.
And these are, again, like newer and therefore more efficient. I mean... Yeah,
and they're called rollout arrays, which is pretty cool, and they were developed in collaboration with Redwire and Made in Space, which is...
And does the rollout mean that they literally unroll?
I think they actually unroll.
Whereas the old one was like an accordion. Mm-hmm. They were folded like a like the blinds in my windows at home fold up. Yeah. We have Top Quark trivia later on today.
Exciting.
What will I segue to that from, Jim? Asteroid news or Enceladus news or giant star news?
Pretty far afield from any of those things. I'd say giant star news.
Okay. All right. Well, let's start with Betelgeuse then.
Betelgeuse.
You remember this back in 2019?
I do. One of the great disappointments of my life.
I know, right? Jim was so excited.
Oh, man.
I was too.
Everybody was.
Everybody was.
Right?
We were hoping that star was going to blow up.
Right. Betelgeuse is this super giant star, which we are pretty sure, based on modeling, is like on the cusp of going supernova, but on the cusp could mean any time
astronomical
in the next
terms,
million-ish years, a half million years, something. And then if you guys remember back in 2019 through early 2020, it dimmed considerably.
It did.
And it was like, is this the...
We were wondering what is going on. We didn't have any good reason why it would be dimming so much. We thought maybe this is some kind of precursor event to the supernova.
And Betelgeuse is a star in the constellation Orion, one of the brightest stars in the night sky.
Right.
So
you've seen the star, whether you recognize it or not.
Right. You've seen it. And you could tell if you had looked at it, before and then after the dimming, oh, wow. It used to be brighter than that other star, and now it's dimmer than that other star.
Yeah.
Right. Well, it looks like we now have a pretty definitive explanation for how this happened. I say definitive, not entirely.
But also, it has re-brightened.
It has re-brightened, so it's back to its kind of normal backgroundish brightness.
Yeah, we were disappointed.
Yeah.
So it did not go supernova. Of course, it still could.
So
just about at any time.
It could do it tomorrow.
It could. And I keep looking up there just to see.
It's just toying with us.
I don't. Yeah. I'm not looking. I figure I'll get somebody will tell me.
Somebody will tell you.
That's the way I find out most things, not from me looking if somebody tells me.
Yeah.
Yeah. So, and this actually is tangentially related to the other topic we'll talk about, a different star dimming. But basically, if a star dims, there's kind of just 2 fundamental reasons why it could dim. Right.
Something happened in the star.
Right. Something fundamentally is happening inside the star, causing it to actually let off less light.
Right. Or something gets in the way.
Or something gets in the way, right? Occults it or eclipses it, something like that. So it turns out, I think in this case, the answer is a little bit of both.
Yeah.
Oh.
So
it's kind of weaselly.
It is weaselly. So Betelgeuse is, a supergiant star that has, just like our sun, it has hot stuff that is rising and cool stuff that's falling. There's constant convection happening in the outer layers, inner layers also, but in the throughout the star, and that can cause regions to be hotter and regions to be cooler depending on what part of the convection cell you're looking at. These convection cells tend to be very large on Betelgeuse, which means that if you're looking at a cool spot, the star will overall look dimmer, right? Because lower temperatures mean less light is being given off.
Sort of very extreme versions of sunspots.
That's right. And in this case, it wasn't just that. So not only were we, were we looking at a cool spot during that time, but also it got cool enough that caused condensation of materials in the region around that. Right, so you have all this stuff that is in the gaseous phase.
The sort of the atmosphere of the star.
Right, the outer atmosphere as far as, I mean, in general, it's hot, and so everything is gaseous, but if it cools off enough, then that stuff can kind of condense into little droplets. Droplets are little solid bits, which block much more light than the gas does.
Yeah.
And then, so you get this double thing where it's cooler inherently, and you have a little bit of this solid stuff blocking it, and the combination of those two things seems to have been what caused the dimming.
When we think about condensation, we're usually thinking about things like water, which is the sort of most common condensable, species in our everyday life. But this could be things like
metals,
iron, going from vapor phase to solids or droplets.
Yeah, it's still
like
very, very hot, but it's like things that,
rocks that and metals that go from the vapor phase to the solid phase.
Like how we form planets.
Yeah.
Exactly. So it's like kind of trying to start to form a planet, of course. Once it warms back up again, then it just tears it apart. And
oblate.
Yeah. So this was based, I think, on a combination of both observations. I mean, Betelgeuse is almost unique among stars in that with our biggest telescopes, we can actually resolve the surface of the star. And so with a combination of a bunch of those measurements and computer modeling to test out plausibility of things, they've determined that this is, and really, once again, we shouldn't say this is definitively absolutely what happened, but this is a model really good match.
That explains the observations.
Yeah, very, very well, matches the data really well.
Just as Niels Bohr's model initially very well matched the spectrum of helium, but turned out to be wrong.
Yep.
So could still be
wrong.
Something else. Yeah. But the other one, the WIT VVV. What is this number 8?
So what does the VVV stand for?
The Vista variable in the Via Lasata survey.
Oh, excellent.
Via Lactea survey.
Huh.
It's the name of the survey.
Fair enough.
So this big star, another giant star, was almost completely blocked out, something like 97% dimmer than normal. And
that's pretty dim.
That's crazy.
Yes, and it was sort of like an eclipsing event. Like Betelgeuse just sort of gradually got dimmer, and the models for this one are sort of done the same way that we look for exoplanets, where you see a star dim because some object passed in front of the star, and you can model the shape of that dimming with time only if there's like a thing there that goes down instead of some sort of amorphous cloud or something like that. This one seems to have been blocked out by something that sort of got a hard edge.
Right.
Or a well-defined edge.
This one is definitely not the, something intrinsic to the star. We have no known ways of taking a star and dimming it by 97%. And with the particular kind of dimming that Josh was just talking about, so yeah, definitely
from the star itself. So this happens. You're saying it's either inside the star or outside the star. So it's something outside the star.
Right.
This particular star it's in our galaxy, of course, and so they tried lots of different models for what could be the thing that causes this. So one possibility is like, is it something close to Earth? Is it something that doesn't have anything to do with that star at all, that just happened to get in the way?
Somewhere in between us and them randomly.
And it turns out
I bet Abby Loeb has a theory for that.
It turns out that for that to be the explanation, there would have to be all sorts of crazy, random, big things floating around out there that are otherwise invisible.
So I take a minor exception to that.
Okay.
I'm not sure. So this was a singular event, or
True.
at least if this is a singular event, then I'm not sure that argument holds a ton of water.
I'm with you on that. It relates to my rant at the last episode.
It does, because a single event,
You have to multiply it by all the chances that something like this could have happened but didn't.
right.
So,
right.
you can't say, oh, well, then there'd be a million of these things in space. No, because we didn't actually see it in front of all the other big stars.
Right. That's the thing is when singular events happen, it's hard to use statistics to analyze. Anyway,
Yeah, they do
you
say
get the
that
idea.
they've identified a couple of other candidates in this survey based on these observations that they're going back to look at.
And once you have that, if you have like a family of things or a number of things that are doing this, then I could buy the statistical argument that for them to be dimmed by random foreground objects, it would have to be way more.
Yeah.
I'm not sure I buy it if it's just this one. But you could certainly say it's unlikely to be a random thing, given the number of random things we know are out there or something like that. So anyway, I guess I buy... it's likely that they're right, but
Yeah.
I think you have to be careful about those arguments.
Yeah, I mean, but like part of the argument is just like this is a thing that's far away, or that it would take a lot of it would just take a lot of stuff to sort of be in there. It's much easier if it's just something close to the
It would be
star.
much easier. The easier I buy,
Yeah.
the fact that there wouldn't have to be a lot of other stuff. There'd have to be one thing, but that's unlikely.
So there have been other examples. There have been other examples, though, of big stars, that they're doing this. Epsilon Aurigae is one. It's a binary star on a 27-year orbit, and it is an eclipsing binary. The primary is an F0 star with supergiant gravity, and the B-type secondary has a big disk around it.
Right. So that's the thing. I mean, when two stars are orbiting each other, they can align so that the star blocks some of the light from the
Right.
background star, and then that causes a little bit of dimming. I guess you're going to get a
Depends
much bigger
on what
dimming.
the other star is,
Right.
in terms of relative brightness or whatever.
But I guess if the star that gets in the way has a big debris disk, then that can block a considerable amount of light.
Yeah.
Right. And that was the idea with this WIT thing is.
And I guess apparently, so there have been 8. This is WIT-08. It is the 8th object that has been dubbed a WIT
And there are like
object.
9 and 10, so
There are?
I think so.
Okay.
Oh.
Yeah, I think it says that there's like an upcoming paper for 9 and 10.
Oh, nice.
Oh,
Okay.
okay.
What is this?
What is it?
10 and 11.
The paper has that sort of conversational tone that goes with like naming an object. What is this? In the paper it says, when it comes to modeling of occultation events, V1400 Centauri springs to mind.
Of course.
Yeah.
But so they think it's probably some sort of debris disk around.
Right.
A binary that's orbiting that star.
Yeah.
Right.
So that's not a debris disk around that star.
Yeah, it's like a complicated. Yeah.
It's a debris disk. Well, they're
Around another
proposing
object.
a debris disk around another object that we
Yeah.
don't see
Yeah.
that is carrying that disk around
Yeah.
this big star.
It's interesting.
Even with that idea, there are some challenges
Yeah.
because
Because why would that disk be there?
right. Well, I mean, we expect disks around stars. So if the other thing is some star that has like some protoplanetary disk around it, that's where you can get a disk. But getting a disk that has these sort of characteristics,
Right,
Yeah.
the sharp edge thing, right?
The
Because
sharp edge
typically, when a debris disk passes in front, you're going to see
you would expect it to peter out.
right. And I guess
Their
that
argument for sharp edge is that there's like pretty specific changes in the opacity in the light curves, and they're not as like opaque
Right.
as they might be.
Right, and it's like
extended
all the
object.
light that is blocked all at once, rather than some
Right.
wavelengths getting blocked first, then other wavelengths,
And
then
that
other
kind
wavelengths.
of rules out tiny particles.
It's not. It's
Right.
there's not like a Dyson sphere around this star.
That's what I'm saying. There is. There friggin' is. All these WITs are alien civilizations.
Alien civilizations. They picked odd stars to set up shop around.
Yeah, it's
Yeah.
not necessarily
Well,
one you'd want.
Yeah, but the spectral characteristics that you were mentioning, Jim, where it's not less dimming at long wavelengths than there is at short wavelengths of
Yeah.
light, which is what you would expect for dust.
Right.
Yeah, it's like across all wavelengths. You see
Yeah.
this
Right,
thing.
right. Because yes, things like dust scatter some light better than other light, and so you're going to see the dimming
Yeah.
differ with wavelength, and this kind of didn't, which is interesting.
Right.
I
So
do-
it suggests biggish particles. So it could still be a disk of particles. It doesn't have to be like a giant solid thing,
Right.
Yeah.
like a Dyson sphere. But those particles in general have to be large enough that they're blocking all the different wavelengths of light that were observed, which is not huge, but still not in astronomical terms what we would typically consider a dusty disk. So,
Yeah. So there's a lot of mystery still surrounding this, a lot of
Yeah.
modeling that needs to be done. We need to figure out what we still don't know the answer to.
How? What?
Exactly.
Why?
yes,
What is this?
What is this? So it's still called what is this? And when if they have a firm answer, then maybe we'll rename it to
This is.
IKWTI.
I know what it is.
Right, I know what this
What
is.
this is.
Yeah.
I do like the title of the paper. It's the giant star that blinked. It's a good
Yeah.
kids book or something.
Yeah.
Yeah.
So does that give you enough to segue to your trivia topic?
Yeah, sure. Because if you
Sure.
really wanted to know what this was, what would you have to do?
Blink a lot.
No.
Oh.
Go there.
Go there. And what would you have to do to go there in some reasonable amount of time?
I would have to be in Star Trek.
You would have to
warp-
travel faster than light.
Yes.
FTL.
That's what I said, I think, Jim.
Right.
There's other lore in which people travel faster.
Yeah,
than
but
light.
those aren't
And
the real
exactly
world.
that
Oh,
is what the
Star
trivia
Trek is the
question
real world.
is about.
I see.
Going faster.
So
than
what I'm
speed
going
of
to do
light.
is,
Okay.
of course, this is in science fiction. This is almost ubiquitous. Faster than light travel, because slower than light travel really makes for boring. Not entirely all the time. Some things do it right.
It puts some
It puts some
difficult
limitations,
constraints on
right.
what you're doing in your whole thing.
That's right. So many sci-fi outlets or franchises use faster than light travel. So what I'm going to do is I'm going to list for you.
Do you know why that is, Jim? Besides just what you just said, it's
No.
because science fiction isn't really about the universe. It's about relationships
Relationships.
and challenges in the human condition.
It is about all of those as well.
And so you just got to get from point A to point B, damn it,
Yep.
to understand all that stuff.
That's right. So how do we get from point A to point B? We have many different systems. I'm going to give you 10 different faster than light travel systems.
Okay.
10.
That's a lot.
I know it's a lot.
Okay, and what are we going to do? Match them to
You're
their
just going to think
universe?
for a minute. Yeah. At the end, what you're going to do is you're going to tell me which universe they're from, and 2 of them I've made up.
Oh,
So you have to.
twist. There's a twist.
You have to tell me what universe
After I
they're
did-
from. A few of them are real easy. A few
Two
of them are
from the
challenging.
universe of Jim's imagination.
That's right.
Okay.
Sounds like a fun place.
It could be, but I have a feeling there'd be a
scary
lot
also.
of fish and stamps there and Scrabble tournaments.
This is a good universe.
Very
Okay.
Firefly-esque.
So here are your, and I'll go through them pretty quickly right now, and then you can
Go.
do
Do
it. 1 is warp drive.
Okay.
2 is hyperdrive.
Okay.
3 is infinite improbability drive.
Oh.
Okay.
4 is FTL drive.
Okay.
5 is the thing flinger. 6 is TARDIS.
Okay.
7 is the Holtzman drive.
Holtzman?
Yeah.
Holtzman.
Lou Holtzman?
I don't know.
Okay.
8 is Starburst. 9 is the boom tube. And 10 is zip drive.
Nice.
So those
I
are
like your choices there.
All right.
It's got a good spectrum from
obvious
obvious to
to-
tricky, sneaky.
yeah.
Yeah. Well, we'll come back to our guesses after we do a little bit of planetary news.
Okay.
Okay.
Yeah. So, Addie, I have good news for you.
Great. Thanks.
There is an asteroid named after you.
Yay! Guess what, Josh? I have great news for you too.
Really?
There's an asteroid named after you.
Whoa!
Yay!
I've got great news for Jim's wife.
There's an asteroid named after her.
too. Yeah.
Oh,
We're really
gosh.
hoping it's an M type, but we don't know.
So,
I sure should have gotten into planetary science.
yep. But you still could come up with
Not
a
too late.
plausible but ultimately incorrect splashy theorem that you would be known for.
That's
so
true. All
that's
right.
still a possibility.
It's not
And
too
you
late
could
to get into planetary.
strive
Jim.
for that.
There you go.
There you go. Yeah.
Well, that's actually a high honor, I think, in the planetary community. So good job, everybody. That just means you've made considerable contribution to
or
the
that there are
asteroid
just a lot
community.
of asteroids.
There are a lot of asteroids.
They are giving away more now. But, yeah.
but
Yeah,
still
so
pretty
you have to
cool.
be nominated, and there's like a little nomination thing. And I don't actually know who nominated us, but
Yeah, and to be clear, this is very different from
yes, the International
the
Star
stars
Registry.
where that you
Star
know you
Registry.
buy for your girlfriend or something like that. I bet you this. Those are just fake.
Yeah.
They're just people taking your money and giving you a piece of paper saying you have a
Right,
star.
nobody spent any money
Now,
for this.
this
to
isn't-
happen.
But it goes into
technically all that more real. This is just a bunch of other people saying
Right.
we've decided
Those
this is the International Astronomical
the
Union,
International
yeah.
Astronomical Union,
which is kind of the the organization that decides the names of things.
right.
decides if they're planets or not.
That as long as people are getting along with each other, are agreeing to go by their decisions
Right.
for what the names of things are.
Yes.
That's right.
And yes, these are the same people that brought you Pluto is not a planet
Right. Right.
and other
Yeah.
great hits. They've now brought us 29605 Joshua Caldwell and 2 something 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 Addie Dove.
there you go.
Yep. It's very exciting.
Yeah.
I don't know.
Both,
Zoe was a little bit weirded out. Hers is just Landsman.
Landsman.
I guess
Yeah.
that maybe it's like the first one that has that last name or something.
But
It's-
it
are there other
varies.
Caldwells
It's
or
like
other
based
Doves?
on what the
I don't think
nominator
so.
suggests, I think, and then also, so like maybe she had a different nominator, and then also like if there's somebody who already had her last name that was named after, it would be more specific. But I don't think there's been another Caldwell
There's
or
no
necessarily
asteroid
a Dove.
Caldwell to my knowledge.
Okay.
So
Yeah.
okay.
it's not clear exactly.
All right. well, whatever.
So they're both, ours are both main belt asteroids, I believe. I think maybe
They have
all
similar
are
eccentricities.
relatively.
Zoe's is a little further out, I think.
Yeah.
But it's bigger.
That tracks.
But it's bigger. Yeah.
Yeah.
That's
And our
exciting.
our other planetary news. Well, we had
And
some
I-
more asteroid planetary news about Psyche that also relates to Zoe Landsman.
does,
the
yeah.
person, not the asteroid.
Yes.
Right.
Who for a while whose thesis work and some other work she's done has shown suggested that Psyche, for everyone, is a asteroid to which the mission Psyche is going.
Yes.
And it is thought to be its big thing is that it's a metallic asteroid. So it's an M-type asteroid, and it's thought to be very metallic. Like it actually probably is some sort of leftover core of a asteroid potentially, where it's sort of like it differentiated. So the iron and metally parts went to the center, and then the rocky parts went up, but then the rocky parts were maybe lost predominantly.
At least that's what the story has been.
Yes, and that's part of the big argument that Psyche, the mission, made actually also,
Right.
was that it's visiting this very unique planet. And it's still a very unique planetary body, but it turns out, and as Zoe suggested, that there's probably a lot more rock there than they thought.
Yeah.
Right. So this is
there's-
a lot of the artist depictions show it like this giant chunk of metal.
With like maybe a crater that's like this big melty splash thing.
Yeah, looks really
Yeah, metal.
metal.
right.
Yeah,
And Zoe's previous work was like sort of nobody else was looking at that at the time. But since then, more people have been looking at Psyche just because there's this mission going to it
Yep.
and doing modeling and trying to understand it a bit better. And there's a new paper out by some of the folks at Arizona who are looking at. So it's interesting because they were doing lab studies and looking at trying to understand some like different mixtures and things like that and what their densities would look like. And so they suggest that Psyche is only 82.5% metal,
that still sounds like a
which
lot.
is still mostly metal. Yeah. But that it might be more rubble pile-y than solid.
Oh, so not a single giant chunk of metal, but
Yeah.
a bunch of different separate
Gathered up
pieces
bits
that
of
are just
metal.
sort of hanging together from their own
And
gravity.
this is partly because it seems to be mostly metal, but its density is too low. So you have to have some way
Some
to make
pore
more
spaces
porosity,
in
more
there.
pore spaces.
I
Yeah.
see. Okay. But then it wouldn't be, but that's kind of still good news for the Psyche mission.
Yeah.
You're still going to see these metallic pieces. The bad news would be if it were like, mostly metal, but differentiated with a sort of veneer of rock or something on the outside, hiding all the
Yeah.
interesting metal you want to look
Because
at.
there's definitely spectroscopic signatures of like pyroxene and other carbonaceous stuff, so other not metally things,
Mm-hmm.
right? And so they looked at sort of some of these mixtures in the lab to try to understand how those looked at compared to the observations we have of the asteroid.
Okay.
And so they showed that you sort of need these mixtures, but then you maybe need a different porosity than we expect.
Yeah, this this frustrates me because this is, like we've said on this before, Zoe has been saying this for years, that Psyche is a very different thing than they have been claiming it was. But she's been saying it kind of too quietly, I think. She's a very,
she's a very loud
reserved
and outspoken, troublemaking kind of person.
Yeah.
So
if she were,
it's odd that for this particular thing she was
Right.
soft-spoken and
yeah. But I feel like when they go there, they're gonna find out that she was right the whole time, but because she didn't say it loud enough, it's like other people, like the authors of this paper. I mean, not that they did anything wrong, but they were going to get the credit for saying that it was not what they thought instead of Zoe. Yeah. So let's listeners of Walkabout, we know that it was Zoe Landsman who originally
And in
said.
fact, we have talked about that on the show
Yep.
before this paper came out.
Absolutely.
Yeah.
So, in fact, we may file a complaint that Walkabout episode, whatever it was, was not cited
in the
as
paper.
a reference in this paper.
It's a good point. It's a good point.
So, speaking of using Earth measurements in a laboratory terrestrial setting to understand an astronomical phenomenon.
We do that a lot. That's most of what we do, in fact.
It is something that you and I do a lot of. Scientists have also taken a look at an Earth analog for Enceladus's infamous tiger stripes. So the Enceladus, one of my favorite moons,
It's a good moon.
is one of the brightest, if not the brightest, object in the solar system in terms of how reflective it is, because it's just
Got to take your
covered
shades when you
with,
go visit it.
It is very, very reflective.
Yeah. It's because it's just ice, like pretty pure ice.
Covered with freshly fallen ice crystals. And those ice crystals are spewing out of these 4 large fissures over the south pole of the moon from a liquid water reservoir beneath the surface of the moon, and instantly, water vapor is coming out, it's crystallizing into solid particles, some of which end up to form Saturn's E-ring, which is kind of awesome in its own right, and some of which snows back down on the surface. And while Cassini was at Saturn for 13 years, we made lots of measurements of these geysers, and roughly, from everything we could tell, the production of that water vapor was pretty constant, but we didn't have continuous measurements, and there were some indications of some variability, but it's tricky to add it all up. How much stuff is actually coming out. It's hard to, figure out a quantity from those things. And then there's the question of what's driving all this? So there's some tidal flexing and heating of the moon that's keeping the ocean warm underneath. And then you have the cracks, and Europa also has these cracks that are formed by tidal stresses as it's orbiting Jupiter. And as the moon orbits Saturn, as Enceladus orbits Saturn, the tidal stresses can cause these fissures to compress, slip, or expand. And that may be related to how much stuff is coming out from them.
Now, quick question. So Enceladus's tidal, so is its orbit fairly eccentric?
It has a forced eccentricity, but its tidal resonant story is nowhere near as obvious as for the Jovian Galilean satellites.
Right. Right, because a bunch of those are in resonance with one another, which force them into these eccentric orbits.
Right.
And that's that's what's going to cause the difference in stretch, right? You're stretched a little bit when you're far away, or more when you're closer, et cetera. And that change in how much you're stretched is the thing.
That happens with Enceladus.
Okay.
Yeah.
It is not in a mean motion resonance, in other words, with Jupiter's famous volcanic moon Io. It orbits exactly 2 times for every 1 orbit of Europa, and 4 times for every 1 orbit of Ganymede, and that periodicity helps drive that non-circularity of the orbit, which gives the tidal stretching changes, or the changing of the stretching that gives you deformation and all that kind of stuff.
Yeah.
So that same process is happening in Enceladus. It's just the story of why there is that eccentricity is not as easily recounted.
Okay, but it is happening. Okay.
It is happening, absolutely.
And this new paper talks about ice quakes
in Antarctica.
What? They're studying the Ross Ice Shelf because it's a large floating expanse of ice that have fractures that are similar to the fractures we see in this tiger stripe features. And they sort of make some predictions of like how often the quakes will occur and then when they occur.
Yeah. And so sort of in the phase of these cracks opening and closing and where Enceladus is in its orbit around Saturn, they're, by looking at the Earth analog, able to make predictions about what these tiger stripes will be doing in terms of slipping and expanding and compressing and things like that. So,
because on Earth and Antarctica, that ice shelf is affected by the tides on Earth.
Right.
So by the tides that you see at the ocean and stuff like that also affect these.
Yeah. So it was a clever idea to, take a look at, well, what do we got going on here that's related to that, and what do you use with that? What do you do with that information? Well, you go, just like you said, you get on one of your warp drive things, go to Enceladus, and warp drive just take you a few minutes.
Nice.
Yeah. So you just hop over to Enceladus. Maybe, I don't know, it's got time for loading and unloading, stowing your bags. Maybe you take a couple hours or a couple days even, something like that, depending on whether you take the scenic route. But then you go there, and we put some landers down on Enceladus, and we start trying to study what's going on there.
Enceladus so bad.
And find out if there's maybe some cool things in that subsurface ocean.
Yes.
So this helps us do all that stuff better.
You never know what's down there.
This would help when is the best time to go ice fishing in Enceladus.
And when you wouldn't want to, because there might be fractures happening and ice quakes.
Yeah. All right, hit us with your trivia then, Jim.
All right, my friends.
All right.
Well, you know some of these. Everybody knows some of these. Tell me, what franchise are the following faster-than-light transportation devices? Number one.
First, in terms of who goes first.
I think everybody, all our listeners will, of course, know Warp Drive is from
Star Trek.
All right, excellent work.
Star Trek.
Good job. 1 for 1, guys. Excellent. Hyperdrive.
Star Wars.
Star Wars. So those are the two big ones, right? Everybody loves Star Trek and Star Wars.
You gotta let us both guess.
Yeah, you cut me off. I might have guessed something else.
You both were going to say that. I will let you both guess on this next one. Infinite Improbability Drive.
It's my turn to go first.
Yeah.
I'm going with Hitchhiker's Guide to the Galaxy.
Hitchhiker's Guide.
Is that way? It sounds familiar.
But I'm not highly confident of that guess at all.
Rick and Morty.
Interesting guess. Josh, you're exactly right. It is the Hitchhiker's Guide to the Galaxy. Excellent job. What about FTL Drive?
FTL.
I go first, right?
Yeah.
This one?
Go first.
Battlestar
Galactica.
Oh.
Old one or new one?
Oh, I only have watched the new one, so new one.
New one.
FTL. F This Life Drive. I will go with Battlestar, but I'm really just riding on Addie's coattails here.
Fair enough. That's a fine set of coattails to ride. That's correct. It is the new version of Battlestar Galactica. It's possible that is in other places as well, because that's faster than light.
But in Battlestar Galactica,
that's what it is.
But in the Battlestar Galactica board game, which is phenomenal.
Yeah, which takes 8 hours to do.
It takes about 6 hours at least to play. It's pretty awesome, though. It's also really hard to find and really expensive.
Yeah, it's odd. Just make some more, damn it.
Yeah.
What the hell?
What about the Thing Flinger?
The Thing Flinger.
The Thing
So
Flinger.
this is one where he wants us to say it's out of the universe of Jim's imagination.
Yeah. Is that a real thing?
The Thing Flinger. I mean, I'm guessing from triple reverse double psychology that it's not out of the universe of Jim's imagination, but I have no idea what else it would be from.
Okay.
So
your guess is?
My guess is Jim.
Futurama.
Futurama. That's an excellent guess. It is Jim, though.
Yeah.
I made that one up.
It was a quadruple, triple, double reverse psychology.
Yes. Excellent. All right. How about the TARDIS?
The TARDIS.
Do I go first?
You go first.
Doctor Who.
Excellent.
Yes.
Yeah.
Excellent. Doctor Who. That one is pretty obvious. Yes. What about the Holtzman Drive?
Lou Holtzman?
You said that again.
That was Lou Holtzman.
I just want to know which Holtzman drive we're talking about.
I don't know.
Who's Lou Holtzman?
I don't know.
Oh.
I just want to know if that's whose drive it was.
Okay. If it is Lou Holtzman.
It's my turn to guess this one, the Holtzman drive.
Holtzman Drive.
I don't know. I'll say I'm going with Jim's universe of imaginary drives.
Yeah, there is one more that is Jim's universe.
I don't know. I don't think it's Jim, but I can't think of another one to guess right now.
because you got to guess. Well, no, there's only one more Jim left.
Yeah.
So.
I'll help you out. It's not Jim.
Okay.
Oh,
And it is
man.
something. I'm sorry, you got that one wrong.
It is what?
It is something that is relevant soon.
Relevant soon. What the hell does
Independence
that
Day.
mean?
No, it's
Oh.
Dune.
Oh, okay.
Which the big Dune movie is coming out. I don't know when.
Okay.
Later this year
Someday.
sometime.
Wow.
Yeah.
Yeah. was not
Dune. I thought that one of you, specifically, I thought Josh might know that because I thought he would have read the Dune.
I did,
I've seen
but
the
that
movie.
was an age ago.
An age ago. Yeah.
An age of Josh ago.
Like 3 days.
All right, just 3 more. Starburst.
Starburst.
Delicious candy. Also a reasonable way of getting from star to star.
I don't know. Dark Star.
Firefly.
No,
Oh.
it's Farscape.
Firefly.
Oh.
Yes, it is.
Yes, see? I thought that you might know
Firefly
that.
is a
You
good
might know
guess.
that.
It.
All right.
Such a good show.
Just 2 more. What about the zip drive?
Zip drive. That's this thing you plug in your 80s computer. So I'm going with Jim on this one. Remember zip drives?
Zip drive,
Yeah,
sure.
Zip drives, you still zip things up.
Yeah, zip
Too.
drive.
It's still like a file format.
Oh, that's
Dot
true.
zip.
Maybe that's what I'm thinking of. And
I think it is. I think it is.
I was imagining there was some kind of old floppy disk, but actually, no.
Zip drive.
It's not one I've already guessed. Maybe it could be. I could reuse one of those. I'm trying to come up with another fun one to use, though. I'll say Jim.
That one is Jim.
Yes.
Okay, that one. I thought that would be a good name for it because
It is a
you
good
zip
name for
along
it.
or you zip space open and go
Yeah,
from one
I
place.
like it.
Anyway,
Yeah.
I thought it was good.
Well, then you should invent that, and that could be the thing you're famously wrong for.
There you go. And then finally, this is a real one because we've
Obviously.
used up both of
Or when
those.
we make the
Is the boom
Astroquarks.
tube
The Astroquarks graphic novel, we can travel via zip
There you
drive.
go.
zip drive?
Well, we'll
And it'll
include.
have fun little zipper. I
We
like
will
it.
include the zip drive in the illustrated guide to Walkabout the Galaxy.
There you go.
Okay. The boom
Last
tube.
one, the boom tube.
I don't know. I don't even.
Give us
There's
a
Star
hint.
Wars and Star Trek. That's
us a
all there
hint.
is.
This one is a whole big universe with all kinds of things, and I've never heard of it.
Discworld.
I mean, I've heard of the world, but not the
boom tube.
boom tube,
Discworld.
not Discworld. That's a good one though.
Thanks.
It's a whole universe.
Is it Nevins? It's Nevins or whoever wrote that.
I don't think
Is it
so.
Discworld?
I've never heard
No,
of it.
somebody else.
No, that's I recognize Terry Pratchett or something like that.
Yeah.
Yeah.
Okay, yeah.
Harry Potter.
Not Harry
I
Potter.
was thinking that because it was funny. I don't know.
This is the DC universe.
Really?
Yeah.
They have something called
They
the
have-
boom
They have
tube.
something called the boom tube, and they
That's
travel around it
ridiculous.
faster than light travel.
Well, that's why they're not doing as
What
well as the Marvel
does-
universe.
Yeah. Who uses that?
I don't
yeah.
know.
Yeah, that's the
I don't
problem.
like it.
I don't know.
That's the problem. Yeah.
I wish the DC anyway. It's not nerd
Yeah.
discussion time right now.
Yeah. Well, it may have felt like your boob tube. Boob tube?
boom tube.
Boom
We're not on
tube.
television, Josh.
May have felt like your boom tube is out of order. It was just another episode of Walkabout the Galaxy. Give us 5 stars and don't blot any of them out. Be sure to follow us on Facebook and Instagram to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where these episodes are eventually posted.
Yeah.
And you can see our music video and eventually some bloopers. But for the moment, all of our bloopers are time sensitive. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Diego Rodriguez is back for much needed production assistance.
Yay.
Thanks to our listeners in Burbank, California and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
Zip, zip, zip.